Good afternoon, everyone, and welcome to the virtual learning course 21st Century Site Performance Case Studies. My name is Sarah Snavely with Timmons Group, and I will be your moderator for today's session. Just a few housekeeping items before we get started. This program will be provided via both audio and web conference. It will last approximately 60 minutes, including Q&A. So if you have questions at any point during today's presentation, go ahead and submit them with the Q&A button at the bottom of your screen. We will get them answered as they come in throughout the presentation. So don't hold back. Let us know what questions you have. Also, please note this presentation is worth 1 AIA HSW credit. So certificates of completion will be sent out via email after the presentation, most likely coming from myself. So be on the lookout for those. And now it is my pleasure to introduce today's speakers, Scott Wiley and Neil Beasley. Scott, take it away.
Great, thanks, Sarah, and welcome everybody. Good afternoon. Thanks for choosing to join us for this session called 21st Century Site Performance. As Sarah said, my name is Scott Wiley, and I'm a principal and group leader of the landscape architecture team across Timmons Group's Virginia offices. I've been with the firm 11 years and have helped to build what I would consider a world-class team of landscape architects, horticulturists, arborists, lead and sites accredited professionals, and visualization specialists, all capable of solving any design or construction challenge thrown our way. With me today is Neil Beasley. Neil's been with Timmons Group for about 15 years now, and for well over a decade before that, Neil was responsible in helping to curate and install and maintain much of the grounds that you see today at Lewis Ginter Botanical Garden. Neil's knowledge of plants and installation and maintenance practices are really unmatched in this region, and we see him as a true asset on any project. In today's session, we'll take you through 4 case studies where we have used the site and landscape as a functioning, thriving environmental tool for measured performance. You might see the word or phrase 21st century site performance and think to yourself, well, what does that really mean? Simply put, I like to equate the performance of a site to our own bodies. Something we can all relate to. How we structure our lifestyle, what we eat, what we drink, how we exercise, how we train our bodies and our brains, all directly impact how well our mental and physical body performs. Site conditions, how we manage and reuse water and other resources on site, and how we prioritize native plant communities, how we allow for people and nature to interact, and how we design many other features of the site, all have direct impacts on how those sites function for us. So these studies today sort of follow and are designed to give examples of how sites can perform better in today's landscape. With that, I'll pass the baton on to Neil, who's going to kick us off with the first case study.
Thank you, Scott. So as you can see on your screen, we're going to talk about 1050 K Street and what we did to provide collection and reuse of urban stormwater. If you want to go ahead and just transfer over to, this is the site that we work with. It's about a half-acre site there to the left with the nice little billboard and gravel and asphalt parking lot. It's beautiful to many people, but in this urban setting, we knew we could do a whole lot better than that. This was a joint project between, as you can see, the Lincoln Company and the Tower Companies. They joined forces together to design this really innovative and highly sustainable project. They wanted to do something new and green, something that they really hadn't done previously. So this is what we had to start with. If you could go to the next slide. The architect on their project was Hickok Cole Architects. This was essentially their concept, this leaf enveloping the building and sort of protecting the built landscape by using innovation and science to both heat, cool, and protect that building. There's sort of these high tech thermal curtain windows. I want to make sure I look at my notes so I say that correctly. That go over this building, kind of envelope this building. We looked at photovoltaics on the roof there. We didn't actually get those on there, but instead we covered the roof with a green roof. You'll see that in some of the pictures coming forward. Next slide, please. I think what's really sort of our contribution to innovation on this project that Scott has alluded to in this presentation is this concept of collecting stormwater and then water from the heating and air conditioning, the condensate, to reuse that water and pump it through these sort of series of plaza features. And why this was so important is that in DC, in Washington, DC, you all may know it's a combined sewer system, a frail combined sewer system. And so at the time we were doing this project, anything that we could do to help preserve and prevent further stressors on that system, we were able to, that we could do on site was a bonus. But you can see we had 2 levels of green roof. The top level you can see is the very top. The second level is the accessible roof. You'll see a picture or 2 of those areas. We collect the water from the 11 stories, heating and air conditioning, as well as rainwater. And then it comes down in sort of this sort of mousetrap way of moving water on site. We collect it into a cistern, and then we can pump it out of that cistern into these fire retention beds that are located at street level. And they hop basically from one bed to the next and through a course of 3 beds, where then it's pumped back into the cistern, and then any kind of excess that we have does go into the storm system. But we're able to recycle all that even by pumping it back up to the roof and using it for irrigation. That's the innovation that we're very proud of this project. And sure, we were confident going into the design, but the first day we saw it all work, we were very relieved because we hadn't done this type of thing before. And we had run the numbers, we knew it was going to work, but we just wanted to see it for ourselves, and sure enough, it worked. So let's look at more pictures of the site. So this is the accessible roof that you see here. We used both extensive and intensive green roof systems. It's a Hydrotech loose laid system up there, but you'll also see in that picture in the background containers where we were asked to plant bamboo on the roof. And when they asked me to put bamboo on the roof, I went, "Are you crazy? That's not where bamboo wants to be." But we made it work. We found a species that would work, and we actually put them in the containers because we knew if we didn't, that the root systems would be inside someone's office downstairs if we didn't protect them. So you go to the next slide. You can see the incredible views that we have from the accessible roof. What you see in the foreground are pervious pavers. They're actually on a pedestal system, and water is able to penetrate through those cracks and is stored on the roof. You can see the plant system, how we were able to take an extensive system and add a few inches of soil by putting these edgers or risers on the perimeters. Starting from a dry condition for stormwater, we can collect a 2-year storm just on the roof, just holding it in soil and in our air pockets within the system, the green roof system. Get to the next slide. This is where most people interact with the landscape, is at the street level. So when we pipe that water into the cistern and then we pump it into the landscape, it emerges out of this sort of rock outcropping, this sort of natural element, and into this bed. You can see where the iris are popping through this sort of depressed area. That's where the water dumps into in the first bioretention cell. You can go to the next slide. There's another view of it, and I want to point out how closely we worked with Hickok Cole in terms of selection of materials. If you look inside the glass in the foyer, you'll see Jerusalem marble on the walls. You will also see we brought that out to the raised bed out in the landscape. And conversely, we also took granite paving from outdoors and ran it indoors. The the glass walls that you see come all the way down to a stone, a decorative stone that goes from inside to out. So it really blurs the line of what's interior and what's exterior. And so pretty good execution and use of materials. You can see the beds in terms of, or in the phase of construction. The larger bed that you see there to the left, the deeper bed, that is part of the bioretention system. And that's the third cell that the water gravity fed to and dumps into there. The perimeter of that deeper area is a traditional raised bed type scenario with planted. And we do not get credit for the product. It's called Coca-Cola that you see there. So we don't get any credit for that, but someone planted that there for us. Not on purpose, but you know, we'll take it. Next slide. This is what it looks like when it's completed in full and planted. You can see, you can't hardly tell where the bioretention beds are, but they're in there behind all this color that you see in the foreground. So that's a completed photo of that bioretention cell. Next. One of the things we want to talk about this project is how successful it was. This project was almost entirely leased before they even opened the building. And you can see one of their first tenants there was the Tesla Corporation. I don't think that they're there today, but that shows you just sort of how successful this project was. People were looking for green projects to be associated with, and this was one of those. Next. And you can see how beautiful that structure is, and in its entirety, and far better from a parking lot.
All right, we're going to take a minute to head down Interstate 95 here from DC and stop off in Woodbridge, Virginia at the Northern Virginia Community College. This was the Arts and Sciences building, and we really, when charged with creating a site that performed more than just a typical landscape, we looked at the theme of arts and sciences and tried to find a way to weave that in so that the landscape really became a teaching tool to enhance the educational experience. And you'll see many ways in which we did that. We feel like it's, having outdoor laboratories are even more important in today's environment, right? As kids are beginning to go back to school, whether it's K-12 or higher ed, they're forced into situations now with COVID where maybe they're not comfortable inside. And so we're finding that there are so many schools with a lack of outdoor environments that create opportunities for learning. And you'll see a couple of ways in which we might have been thinking about this long before the days of COVID. The site itself is shown right there just beyond the retention pond. This is an infill project adjacent to a large stormwater campus, a stormwater pond on campus. There was an additional complication that we realized early on with this site, that this stormwater pond had an RPA, a resource protection area, that bounded the pond, which is, if you know anything about RPAs, it's typically associated with perennial streams, not necessarily around larger water bodies like this. So immediately, we were thrown into a situation where we couldn't put any buildings, major impervious cover, furnishings, or heavy design elements into that RPA. And we were forced to condense this design of the site a bit, which actually led to a couple of opportunities that we'll get to in a moment. The RPA restrictions forced us to use some pervious pavers at the outdoor learning area that was just behind the green roof on the pond side, the rear side of the building. We used that to create a riparian fringe planting community through a series of flow-through planters and bioretention planters, very similar to those images you saw in DC at 1050 K Street, where water flows from one to another, being filtered all along the way. In this case, ultimately, before it reaches the retention pond, creating cleaner water that enters the pond. But taking a step back, we looked at this site to replicate 4 Virginia ecological plant communities as defined by the Department of Natural Resources. And we clustered them around the site based on their function and form in the landscape and ability to tolerate different microclimates. The 4 habitats that we created were the riverside prairies, rocky bars and shores, Piedmont alluvial forest, and the eastern Hemlock hardwood forest ecosystem. The establishment of habitat, seasonal color, and biodiversity creates an ever-changing landscape experience, and one that's aligned with sort of a new shift in aesthetics. To hone in on one of those ecosystems, we'll talk a little bit about the eastern Hemlock hardwood forest. As landscape architects, I feel like we have a responsibility to provide future generations with sustainable environment that's supported by regenerative natural ecosystems. Selecting indigenous plant communities such as the eastern Hemlock hardwood forest is essential to reestablishing this type of habitat, one that is declining in our state and in our region, that in turn also reduces the need for excessive irrigation and use of chemicals in the landscape. So we look at ways to do this in areas that also double for other functions. The eastern Hemlock hardwood forest also acts as a nice screen, a visual screen and a wind screen. In this case, separates the front door of the building from the main service area around the back. And so it created a nice windbreak and visual screen as well. In these images, you can really see how the days of green fescue lawns and manicured clipped hedges are gone in many landscapes. This is a shift in the aesthetic that is happening, and there needs to be a shift in expectations from people using these spaces and experiencing these spaces, as well as the people that are maintaining them. So we took the time at the end of this project to prepare a pretty detailed maintenance manual, and we reviewed it with the staff and personnel on site to make sure that it was cared for in a way that we wanted it to. Oftentimes we see these landscapes that are sort of meant to be managed loosely and curated to have a somewhat wild look. We see them be over-maintained, and in the end, they turn into something that no one had ever intended them to turn into. It's a more managed look. Some of the species die out. You lose some of that natural feeling. And it was important to communicate that with some of the maintenance staff up front. Another benefit of having native plants and ground cover communities are that they maximize lead credit opportunities for reestablishing habitat in lieu of planting a monoculture of native lawns. This was a lead project, and we were striving for over 60% of the site. It was a 9-acre site in totality for the whole lead boundary, and 62% of that needed to be restored or protected as beneficial native habitat. You'll see some strategies on how we have done that moving forward. 2 green roofs that total about 2,500 square feet were strategically located to mitigate stormwater runoff on the roof, slow the volume of that runoff, and improve the quality of the water hitting the rest of the treatment train below it. These roofs were accessible, and we made sure that they were accessible for demonstration and maintenance by the maintenance staff, and demonstration for the student group, so they could get up there and understand the layers that go into this, why they're important for filtering water, and what it does to an ecosystem, what it does to help cool the building, and so forth. And so it's a teaching tool again. In this situation, unlike the 1050K project, we used a different product called a live roof system. This is a tray system, as you can see. There are many benefits to using tray systems. One is that they're modular. They're very easy to grow in greenhouses. They're easy to ship in and install. They install very quickly. And they're easy to also replace if a certain tray or species doesn't do well. They're easy to replace over time. And so the live roof system has proven to be a successful application here. But ultimately, this is the first step of that treatment train. After water filters through the green roof, it's then gone through the downspouts and into a 15,000-gallon cistern system that helps to irrigate the entirety of the green roofs and the rest of the half-acre landscape beds around the site. That treatment train comes down through the downspouts and ultimately into a series of 3 5,000-gallon cisterns. You can see in the background of this image how we've used permeable pavers to trace around those 3 cisterns that are directly below the surface. Again, further telling the story of the water cycle throughout the site. We worked with Grimm & Parker, who's the architect on the project, to help tell that story. As you all know, part of any LEED project is helping to educate those about the green improvements that were made as a part of the project. And so here's just an example of the teaching tool that this can become for students and people who are using the site. In the foreground, you'll see more of the bioretention areas, the flow-through planters. In the background, you see a large, student gathering area, doubles as an outdoor dining plaza. Right now, they're using it as outdoor classroom space, but those permeable pavers allow the water to trickle through, get caught in the gravel layer below, and ultimately go through the treatment train of the flow-through planters, and then into the retention pond nearby. Again, you're seeing the rocky bars and shores and prairie ecosystems being emulated through these plantings in the foreground. As we flip around to the front of the project, we find areas where we can create opportunities that are, challenging situations. This particular area was the front door of the building, and we had about a 10 or 12 foot grade differential to make up. And they didn't want to just cut the whole site down and haul the dirt off site. So we had to come up with an aesthetically pleasing wall solution or some way to make up that grade. And tying in the theme of the arts and sciences building, we thought, okay, this could be a great tapestry for art, but in the form of plants. Typically, we're looking down on landscape plans and designing them from a plan view, from a bird's eye perspective. In this application, we tilted it up, much like a canvas, and got to design, the intertwinings of native and adaptive species that could also have lots of pollinator benefits right here in the landscape. And as an art kind of tapestry, we found that the students, as certain species might decline for some reason or get too large for their space, they're being plucked out and a new tapestry is being created. So it's a constantly changing expression of art that's right there at the front door on campus. This system is called Smartslope. It's a stacked wall system that has specially designed cavities in it to hold planter soil and allow those plants to really thrive. That can be coupled with irrigation from the backside that is supplied by a lot of the water treatment train and cisterns on site. So it's a really great solution to a challenging problem here at the outset. As part of the LEED boundary, the entrance to the campus provided an opportunity for an alternative lawn species called eco lawn to be introduced that really transitions from the native knee-high meadow in the background to more of the manicured sidewalk edge. That eco lawn is a unique kind of low maintenance, low impact ground cover solution, and it's alternative to conventional turf. It's a blend of fine fescues. It's available as seed or sod, and it forms a slow growing, drought tolerant turf. And that's important in these LEED applications, is that we can get credit for this type of solution and also reduce the need for mowing and fertilization. A typical lawn is mowed 25 to 30 times a year. In this eco lawn, only requires mowing twice per growing season. So it's a great solution to cut down on some maintenance. Left alone, it tops out at 6 to 8 inches and is a really nice alternative to conventional fescue turf. We've estimated and verified this with some of the staff there that roughly $10,000 a year are saved in the reduced maintenance costs across 3 acres of this type of alternative lawn cover. And that savings is done through mowing, watering, and typical, traditional chemical applications. And so this project has been a great solution here, and we've used it in many projects since. And of course, I think with every project, we have a couple of wow shots. I think for the architects tuning in, the building itself also designed to LEED silver. Just a really spectacular building. Can.
Questions regarding Smartslope. Did the Smartslope planting need to be irrigated, and how was that accomplished?
Great question, and the answer is yes. It does need to be irrigated to really thrive. There may be a few really tough as nails plants that would do okay with the watering conditions that we get in our Virginia climate, but typically we would recommend irrigating it. And that irrigation system happens behind the wall. It's through a series of drip emitters basically that are plugged into each cavity where the soil mass is in each little unit. And that's just done as a trickle, a slow trickle to irrigate that wall system. It's a great question.
How does the Smartslope wall compare in cost to other retaining wall systems?
It's been a while since we've looked at cost figures on the Smartslope, honestly. It's not a system we use every day. We might have only used it twice. But I can tell you that the actual block itself is relatively comparable to a stacked block system that you would see in many applications today. Where you're adding cost is the soil and the voids, the irrigation, and the plants themselves. So I do think you're looking at potentially 30 to 50% more in cost in general in terms of a traditional wall system. Great questions. Keep them coming. All right, Neil, we'll let you take it away and talk through our next module.
All right, so we've talked about a small site developed by a private developer. We've gone to a community college on a campus setting. We now will talk about a U.S. federal government project. The Social Security Administration National Support Center was a project that we worked with the U.S. General Services Administration, and we're focusing on restoring biodiversity while still mindful of both operations and maintenance. Thanks. You can see the location and relative to Washington, D.C. My understanding is the GSA looked at over 150 sites across the country and settled on one near to, Washington, D.C. and a little town called Urbana off of I-270. Sort of north of Washington, D.C. You can see in the picture here, the data center is there to your right. The operations or the administration offices are there to the left. In total, it's a 300,000 square foot project, but the majority of it is behind that wall in the data center that's managing all the data. Next slide. You can see here how the site was arranged. It's a 65-acre site. One of the challenges of this project was for the GSA to take on or have the safety and the security needs of the project, but now they've got 65 acres that they're going to have to maintain. So the objective was to create a secure facility, but also one, again, mindful of maintenance and is a sustainable site. You can see there to the left, parking lot, the main building in the middle, and then to the right, those are photovoltaic panels. One aspect of this project is it had to operate even under the most stressful circumstances. So there are multiple sources of power as backup, both in generators and also in renewable energy to service this building. Next slide. This is what we started with. You can see there on the right, it's this sort of rolling hillside. It's basically hay fields bisected by hedgerows and tree stands. When we started to place the building on this site, well, we had some standoff zones that we had to adhere to. And so the building naturally was going to fall into the middle of the site. Well, that happened to be the high point of the site. So we created these sort of three edges that you see here. This structured edge to the left is where we connect to the neighboring office park. And that's where your arrival would come into play. That's where the parking ended up, as you saw in the previous slide. Along the bottom of the site, along to I-270, we had that reinforced edge. And so we've got some slope in there. We've got some existing vegetation that we want to take advantage of. But we wanted to make sure we were protected visually from the I-270 corridor. And then there to the top, you see the natural edge. There's a stream that runs down in that low area. And so we're transferring to just pure views to the natural landscape off of that edge. So that kind of gives you the perimeter and how we handle that. Next slide. You can see how it works into play here. There's basically 5 primary elements to the project. You see the entrance gate in your foreground. You see the parking lot to your left. The structure that's right in front of the parking lot is basically your check-in station. Then you have the data center, that's just your biggest area of building there in the top of your screen. And you can see that, relatively speaking, the office and administration area to the left. I want to point out in this picture, you can see some of the site elements that come into play later. One is stormwater. So stormwater was handled in the lowest part of the site. So you can see there's a smaller area of stormwater there towards the middle right of your screen. And then the top right, you can see a larger stormwater collection pond. You can also see the photovoltaic panels up by that pond, and that's because that's our south-facing slope, and it worked perfect for placing those. And over to the left, you'll see kind of a curved dark line. That's actually a security fence. We had 2 security fence distances on this project, 150 feet and then 400 feet. So there were basically 2 layers of fencing on this project, which is why this site was selected, because it had the capacity to handle those separation distances and be able to then also handle the building as well. Next slide. So I mentioned the that sort of reinforced edge off of 270. We spent right much time looking at view sheds from the road, looking at slope analysis, and figured out how and what angles that we need to build and add to and vegetate so that we prevented you from being able to see the building from I-270. Quite the chore. We were given a big building. We were told put it on the top of a hill, and then we don't want anybody to see it. And so we tried very hard to make sure once we planted this and it grew that you can't see the building. And I will attest, I've driven there recently, and you will never know that that building is sitting there because of the vegetation. So our plan worked. Other sort of transitions on the site. So this is the connection to the sort of the structured edge that we talked about. We separated ourselves from that area using a berm. That's part of the security. We did a couple different options of where fencing would go. We showed how the landscaping would be implemented, but that security aspect of this project was huge. We had to meet all the security requirements to make this project work. But then again, half of this site only had structures on it, parking, buildings, that type of thing. The rest of the site, 32 acres of it, was left to be natural. The GSA was not used to this. They didn't know what to do with it. And so our job was to come in and basically heal this landscape and take it back to what it was previously. So a majority of that was meadows. And you can see how we created exhibits showing species through the seasons, what they would look like, and so forth. Next slide. We also had ecosystems. Scott talked about ecosystems on the community college projects, but we also did this here. We worked with the local forester. I remember being on the phone with him and talking about, you know, which species are best for this area. What is the habitat that we're trying to create on this site? Because remember, 32 acres, we got to do something with it. And so you can see how we've done analysis on seasonality of species, and there was about 5 different ecosystems that we incorporated on the site. Thanks. Even in the parking lot, we were looking at ecosystems and what plant selections we could put in there that would survive. But again, security, paramount on this project. So SEPTED is something, crime prevention through environmental design, that I know many of you know about. We used that and obeyed that on this project. You can see the clear zone between the pavement to the bottom of the trees. That's all strategic. We want that clear view between 2.5, 3 feet and 6 feet. And you can see that in these sections. Next. This is the check-in facility. We call it the FAC. I've sort of forgotten what that stands for, but you can see how you enter into the perimeter, the 150-foot perimeter of the site. That's your check-in. And so that's basically your first introduction to structures on the site. Next slide. As you exit that building, this is your journey to the operations center. It's this long walk you can see there. It was so long we included some benches to make sure someone could have a chance to take a rest. But the sort of sculptural nature of the landscape just makes that part of the journey, this sort of preparation or cleansing experience before you enter into the facility. You can see it.
Vegetation slides, a couple slides earlier.
Yes.
All the existing vegetation, were you dealing with any invasive species?
Invasive species, is that what you said?
Yeah.
This was a pretty clean site. Most of the invasive species that we dealt with were in the meadow areas. So we had some thistle come up in the meadows as it was establishing, and had to pull in some experts and meet with the maintenance staff to actually come up with strategies on how we tackle those invasive species, undesirable species as well. But yes, we did have some we encountered, but most of it was in the meadow areas. You can see here, this is the operations side of the structure. There was a fire lane that we had to put in around the entire building, and we also have a 35-foot standoff distance where we can't grow anything more than 6 inches in height. So we structured our plant schedules and our selections to where we knew we could maintain that 6-inch maximum height, but we also have some flowering species in there. You can see that in the foreground. So we don't miss an opportunity to try to beautify the site, even when we're kind of handcuffed in terms of what we can do for the security aspect. So you can still hear me, right, Sarah? Yeah. Okay, good. This project was so detailed and specialized in terms of what we did with the site. We had a lot of questions from the GSA on how does it work? You know, tell me everything that you've done here. And so we actually took all of the different systems, the hydrology, the vegetation, and the different ecosystems that we established, and created posters. These posters still now hang in the hallway of the support center so that everyone can learn, you know, what's significant about the 65 acres of the place that they work and how it's working. We did collect water in a cistern. We've repiped that for some irrigation up and around the main entrance and the parking lots. And you can see there, you know, we talked about that hydrology and all the different benefits. We talked about the vegetation with, you know, we had some 31 pollinator species, close to 50 total species that we brought back to the site. So we wanted to tell that story. And then the different ecosystems I've talked about in some of the slides as well. So in the end, you know, this is a statement that came from the GSA that, you know, with the new technology and the innovation, they save $626,000 annually on electricity costs. We know from the landscape that a typical mowing of 62 acres would cost about $30,000 a year. Because we put meadows in, we reduced that to two mowings, basically just cutting down that material twice a year to about $5,000. So we've cut out $25,000 a year just in maintaining the grass or lawn areas on the project. So anyway, Innovation saves money. It just takes some forethought and integration of those sustainable practices to make the site work.
That's great. Thanks, Neil, for taking us through that last session. So you're starting to see a trend in the last 3 case studies and how we're thinking about our sites. We're thinking about the performance, the way we treat the ecosystems and the landscape. We heal the sites. We're integrating that with water capture and reuse. I think that's really important in today's world of site design, and we want to do that whenever we can. As we flip down to stone brewing, it has a few of these elements and some, I think, really important measures that are in place. But really, we want to make sure we talk about something that's fun. It's Thursday. Everyone's probably craving a beer by now. So we're going to take you down to Stone Brewing Company here in our backyard in Richmond and talk a little bit about that unique project. I think the main theme of this project is really the urban wild. And that's a trend that started maybe 10 years ago or so and has been building ever since. And you're seeing a lot of it in the urban landscape. And this was one of the first ones that we were able to be a part of that really looked at the site before it was constructed, understood all of the elements that were there, and tried to pick it apart and reuse some of those elements in different ways. And that was really important to the client as well. So we got to have a lot of fun with this one. But first, to set the stage, over the last 10 years or so, Timmins Group has worked in all of these different areas within the Fulton community, Rockets Landing, the Capitol Trail, the Intermediate Terminal, projects along the James River, Richmond on the James is a multifamily project under construction, Fulton Gas Works that's being transformed, and then the Stone Brewing Company right there along Gillies Creek. So we're really ingrained in this area as a firm, and the work we've done has just been building on each other, and it's really rewarding to get to continue that through this Stone project. But we help Stone Brewing Company by leading the site selection process for the city of Richmond, narrowing down their top 15 sites down to this single site to put forth through the RFP response process. Over 350 RFPs responses were issued to Stone, and ultimately they chose this site for several reasons. I think most critically to an East Coast distribution facility was its proximity along I-95 with easy access west to 64, east and west to 64. Also important was its location along the James River, and you'll see how that comes into play in a moment. But this site is right at the end of the navigable channel from the Chesapeake Bay up the James River to what we call the intermediate terminal site. That has a great history here in Richmond as well. And so that comes into play. It has proximity along rail lines and the BRT and the Capitol Trail and all within the Fulton neighborhood. So really interesting site with lots of activity and things converging in this one location. It also had proximity to many different recreational avenues. The Gillies Creek Greenway that's planned in the city, the Captain John Smith Blueway along the James River, as we said, the Capitol Trail, the newly aligned Main Street improvements in the area. And so Stone really got behind all of that and thought this was the best site for them because there was so much going on in a city that was growing in popularity and with its outdoor scene. And so we really used that as a design driver throughout the way as well. The proximity to the river was really important. You can see in the background there's a barge on the James River at the intermediate terminal that's offloading the giant canisters. Those are their brewing barrels. They were just brought in by a crane and set up into place right on site. And so they brought those in from Germany, shipped them all the way across the ocean into the bay, up the James River, and right here on site. So talk about efficient arrival. That was certainly it. Each of those fermenting tanks holds 1,000 barrels of beer, which is roughly 248,000 pints of beer. So the capacity at this facility is quite amazing. Looking at the site, the project encompasses about 200,000 square feet on 14 acres of highly urban and previously developed soils. There are 3 main entrances to the site, the public entrance, truck entrance, and employee entrance. And all along, the users and the people of the Fulton community really wanted that main entrance to be at the corner of Williamsburg Avenue and Nicholson Street. But Stone saw, this as a different opportunity to really rely on Gillies Creek as the front door, create a parking lot across, and bring people through that experience into their front door. They thought that was more important. And so we helped them sort of dream up how that could happen. As we flip to the next slide, we're looking at how we approach the stormwater for the project. Many of these have the similar treatment train where you're looking at runoff from the roof, from all the surface, parking lot, and hardscape areas into treatment levels of some sort before going downstream into the ultimate drainage channel. Here it was handled in a traditional way that meets Virginia's regulations, treating for both quantity and quality of runoff on site. This particular treatment train starts with ground-mounted filteras on the ground plane and roof-mounted filteras. This was new for us on this project, but treating the water as much as possible right at the source before going through the downspouts, before getting into the bioretention cells that had treatment forebays, and ultimately going down into Gillies Creek and into the James River. So the goal is to create as clean of water as we can before it does that. So an interesting client rooted in the West Coast, Stone worked with us to really focus on reclamation of the urban relics on site and how we could reuse those materials in the design of the outdoor spaces. This space, as the brewery opens up from the COVID pandemic, has become a really important space for them. And we never realized how much it would be utilized until it's the only space that's functional for them. And so we've gotten a lot of accolades for how we've handled this and been able to reclaim some of those materials. Some of the specifics, the boulders around the project were found on site, and they were also supplemented by others that Horrigan, the GC at the time, was using on a project up the street at the University of Richmond. So local boulders were used and placed on site to help create different grade breaks, cause seating areas, and just other elements in the urban landscape. An old oil tank was found in a pile of rubble on site, and most people would think to just chuck that in the trash. They saw that as an opportunity for art and tilted it up in place and positioned it within the landscape, and you'll see an iconic photo of that soon. The seat walls and blocks were formed using old bulk material storage walls that were on site, and we tilted those up as grade breaks and seating areas. The wood and the picnic tables and the beer ledges that are around this beer garden were taken from some of the trees that existed on site, planed and sanded down to be reused into those furnishing pieces. The stone dust paving was crushed on site, and the detailing of these features became super unique and challenging as to how we have all of these existing materials woven together so that none of the toxic properties that might have existed prior to the site were present in the end. Two of the more interesting features were the concrete plaza and the pedestrian bridge. The concrete itself, you can see the irregular pattern on the page here, was an acid-stained concrete that we wanted to put control joints in to make sure that it wouldn't crack, or if it did, it was cracking in a way that we wanted it to, typical concrete construction. The client said, no, we don't want any control joints. We want you to take those out. We want this thing to crack organically, and that's okay. We want little weeds to pop up in those cracks over time. We want that really wild urban look. And so we had to shift our mindset a little bit. And in a way, the client educated and trained us in this new, shift in landscape thinking. So it was really interesting to be involved in that process. Finally, the pedestrian bridge. We found this on Craigslist somewhere up in Pennsylvania, and Stone had it shipped down on two 18-wheelers down Interstate 95 and ultimately put them into place over Gillies Creek. We had this designed as a single span bridge from the parking lot over to this main beer garden and had to kind of adjust on the fly when they told us that this was going to be a double span system with a platform in the middle. But as you'll see later, that platform proved as another design opportunity for us. So looking at some of the imagery, here's an example of how they took this old oil drum on site and turned it up as a landscape element. I love this photo. It's so iconic because you see so many of these found elements, the bulk material storage walls in the foreground that are used as seating, the oil drum, the bridge that came down I-95 from Pennsylvania, Gillies Creek that it goes over. You have the relics of Fulton Gas Works in the background, and then the city skyline. And so These images are really important in that urban wild, those native plants that you see woven throughout and some of the hillside beyond are sort of the tapestry that holds it all together. I love some of these detail shots too, because they show how the materials come together. Something as simple as a crushed stone, paving adjacent to a 3-to-1 slope going down to the creek needs some sort of edge. And so reusing some of the stone on site in a way that allows water to funnel through these little tiny runnels and still go off site without creating a lot of runoff was really key. Here's an overall shot of the bridge. The city is talking about one day taking up Gillies Creek and putting it back in the form of stream restoration. So removing the concrete channels and placing back more of a natural stream edge. And I think this will be really important to go along with Stone's image of being as natural and environmentally friendly as possible. And so we look forward to the day when that might happen. The platform that you see between the 2 spans and the bridges also serves as a set of steps that can go down to the Gillies Creek Greenway that is planned to be built very soon. Taking a look at the landscape plan, it was a different way of looking at the landscape too. You're not seeing long linear hedges. You're seeing very organic, shapes and formations and groupings of plants. This was really important. We probably went through 10 iterations of the landscape plan on this project with Stone, carefully picking out each plant and each cluster and how they interacted with each other and how they looked next to each other to make sure they got the look that they wanted. This really naturalized urban look. You see some of the species we've chosen, primarily sticking to a native plant palette. Very successful in our area, require a lot less water demands and maintenance demands over time, but provide the benefits of habitat and everything else that these types of urban sites need. And finally, I love this image because along with the urban wild landscape comes a different type of maintenance, right? Especially to a brand like Stone, who wants to cut down on their mowing needs. They rented goats and had staff from Groundwork RVA. It's a local nonprofit organization that helps to train folks in landscape maintenance, helps to get them, trained up so that they can provide or obtain real jobs in the workplace. They've leaned on these types of techniques to help manage their site and used that as an education and teaching tool in the community, kind of giving back to the Fulton neighborhood as well. So we'll end with that. A nice shot across the bridge to a Thursday afternoon at 5 o'clock, which will be here very soon. At this time, I know we ended, a few minutes early. We still have some time for questions. So if Sarah, if you have any that have come in, we'd be happy to take those now. Otherwise, feel free to type in. And if there are no questions, we just wanted to take a minute to say thank you for your time. We appreciate you tuning in this afternoon.
We do have a question here. Is the beer garden completely handicap accessible?
Sarah, we lost your audio for that last part of the question. Can you try that again?
Sorry about that. How about now? Can you hear me okay?
Can hear you now.
Okay. Is the beer garden completely handicap accessible?
No, we lost you again. Let me see if I can find the chat question. Let's see.
Is the beer garden completely handicap accessible?
Okay, there you go. Great question, and I can flip back to a plan. So the beer garden is 95% accessible. You'll see in this image here, the grade of the pedestrian bridge spans are very much level with the front door of the building and the outdoor beer garden. The grade also meets up nicely with the parking lot on the other side. There's a couple accessible spaces there. So that's the main accessible route to the building. The crushed stone, the ADA code requires a firm and stable surface. And while there's some loose interpretation into what that could be as a surfacing material, crushed stone of this type of aggregate, as long as it's coarse and angular and not rounded, often does meet that ADA code. So the materials we used here were fully accessible with the exception of the small area you see on the staircase going down to just a private little area. in space that is not accessible, but otherwise was.
Okay. While we're waiting for more questions to roll in, I just want to remind everybody that this is worth one AIA LU credit. So certificates of completion will be sent out to everyone who participated today. So, and if there aren't any more questions, I think y'all must have done a great job of answering those as they're coming in. We appreciate your time, and we appreciate everybody jumping on here and listening and joining us today. So have a great rest of the week, and thanks again.
Great. Thanks, Sarah. Thanks everybody for tuning in.
Bye everyone. Have a great one.